I'm going to start the recording then. Okay, so today's lesson is we're going to focus initially on the Z interval for the population mean. And again, we use the Z interval. Is it recording? Can y'all tell? Stop the share and make sure. Yeah, it is. Okay.
Yeah, I was going to say it's recording.
Okay, thank you.
You're
Okay,
welcome.
so the Z interval for the mean, and we use Z whenever the population standard deviation is known. Last Wednesday, we looked at an example, but in case you've forgotten, the keystrokes for Minitab are on slide 9 of the PowerPoint for the Z interval. You can be given the summary statistics, or you can be given the raw data. And we're going to look at an example of both here in just a minute. But the keystrokes, if you need them, are on slide 9. One of the manual calculations that you have to do related to the confidence intervals is the error bound for the population mean. Remember, error bound for the population mean, that EBM is error, bound for the population mean, which is the fancy-dancy statistical term for margin of error. It's EBM, and it is the same as the margin of error. How much could my estimate be off? Okay, it's called the margin of error. It's similar to the margin of error. Again, we just use fancy language. And it is one of the few calculations that Minitab does not do for you. Okay, so it is a calculation we will do by hand using a calculator. Also, I gave you basically the phrasing that you will use each time you write the conclusion. That is on slide 11 of the PowerPoint. And we're going to pick back up with example number 2. We did example 1 last week at the end of class. So I moved these over to the Word document just because it's a little bit easier to deal with them in the Word document. So let's begin. It says, noise levels at area hospitals were measured in decibels. The mean of the noise levels in 84 hospital corridors was 61.2 decibels, and the population standard deviation was 7.9 decibels. Find the 99% confidence interval for the true population mean. Now remember, in most of these confidence level problems, you're going to be given all of the information that you need. The first thing that I notice about this problem, and it's important for you to notice, is that it gives me the population standard deviation. So because I know the population standard deviation, I'm going to calculate a Z interval. Okay, so we do a Z interval because I know the population standard deviation. Now I realize at this particular point that that's really the only one that we've talked about. But by the end of today, we will have talked about 3 different confidence intervals. We will have talked about Z, we will have talked about T, and we will have talked about proportion. Okay, so on the midterm that's coming up, you're going to have to be able to recognize, should you do Z, should you do T, or should you do a proportion? So I'm trying to help you recognize when to do which one. Okay, so we know we're going to do a Z, and then it helps us to identify all of our information. And usually there's questions with the problem that'll ask you these things, but usually we need X bar, which is our sample mean. We have sigma, which is our population standard deviation. We need N, which is our sample size. And we need the confidence level, which I usually abbreviate CL. All of that information is given in the problem. So if I skim back through, it says the mean in 84 hospital corridors. So my sample size is 84. The mean was 61.2, and the population standard deviation was 7.9. Find the 99% confidence level. So all of the information that is given in the problem. Now, it's also important to note that in this scenario, what you have is what Minitab calls summarized data. Okay, you do have to recognize that, because remember on slide, was it 9? You have the steps for summarized statistics or the steps for raw data. Remember, raw data is where they list out the data or list out the numbers. So this problem is summarized data. So then I need to go out to Minitab and get my values. Okay. So let me scroll down a little bit. All right. So going over to Minitab, we would do stat, basic statistics, 1 sample Z. Again, we're using Z because we know the population standard deviation. I have summarized data. My sample size given in the problem was 84. The sample mean given in the problem was 61.2. The known population standard deviation was 7.9. I go to options. I want the 99% confidence interval, so I need to change this to 99. My alternative hypothesis always stays at not equal. I click OK. OK. And we get our results. Okay, and I'm going to copy them over to our paper. Yeah, that's what I thought you were going to do. Okay, let me see if I can get it in the right spot. It's wanting to be difficult this morning. Okay, so it gives us, again, when you get this printout, it shows you several things, okay? It reminds you what your sample size is, so you can make sure you didn't type it in incorrectly. It reminds you of the sample mean. It also does show the known standard deviation, which is your population standard deviation. The piece that we're really looking for is this 99% CI per mu. Just as a side note, you don't need SE mean. Okay, so you have these numbers, 58.980, comma, 63.420. The first number in that parenthesis is the lower bound for your confidence interval. That's the smallest value that the population mean could be. The second number is the upper bound. So I know usually on the homework, on the midterm, it's going to ask you what is the lower bound. So you would simply write down 58.980. It's going to ask you what is the upper bound, and you would write down 63.420. Both of those items come from the Minitab output. Usually the next question asks you for the error bound for the mean. Okay, remember this is a hand calculation using the formula and a calculator. The formula is the upper bound minus the lower bound divided by 2. Notice, guys, that I did put parentheses around the upper bound minus the lower bound, which implies we need to do that subtraction first. So I have 63.420 minus 58.980, all divided by 2. So I'm going to get my calculator and do that subtraction. 63.420 minus 58.980 gives me 4.44 divided by 2 is 2.22. So the error bound margin for this problem is 2.22. The last step is to write your conclusion. And we write, we estimate with 99% confidence that the true population mean noise level is between 58.980 decibels and 63.420 decibels. Now, a couple of things I want to point out about that conclusion. It's important that you say true population mean, and then you describe whatever that mean is, because if you go back to the question asks you to find the confidence interval for the true population mean. And in this problem, we were talking about noise levels. Okay, so I had to identify that. I have that formatted. If you can't remember that format, I'll be doing it as we go through the examples this morning. But remember, that format was on slide 11, and we're simply filling in the blanks. I have to put my confidence level. I have to include the context of the problem, meaning what is the variable, and then I have to do the lower bound and the upper bound. Okay, so that phrasing really doesn't change. As you get familiar with it or more experienced, there may be other ways to say it, but I would strongly encourage you to stick with the format that I'm giving you. Questions? Okay, the next question says, suppose scores on pop quizzes in statistics are normally distributed with an unknown population mean and a population standard deviation of 2. A random sample of 22 scores is taken and are listed here. Find a 90% confidence interval for the true population mean of statistics pop quiz scores. Okay, so two things that I see. One is it does give me the population standard deviation. So because I know the population standard deviation, I am going to do a z-interval. Okay, we do a z-interval because I know the population standard deviation, which is sigma. What is different about this example and the previous one is that in this example, I'm given the list of 22 scores. I'm given the raw data. I'm not told in this problem the sample mean is this, the sample size is this. It actually does tell us the sample size, but it does give us the confidence level. I could still work the problem. I just have to slightly change the command. So this problem is an example where you're given the raw data, but it is a z-interval because I know the population standard deviation. Okay, so I have to enter that data, but to think about initially, I don't know the sample mean. Minitab will figure it out for me. I have the population standard deviation. I still need the sample size. And I need the confidence level. The confidence level in the last sentence, it says, find a 90% confidence interval. It tells me that my population standard deviation is 2 points. I have that underlined in black back up top. I don't initially know the sample mean. It does, however, tell me that we use a random sample of 22 scores. But even if it didn't tell me that, guys, I could count to see how many data values are given. So my sample size here is 22. I have the raw data. I'm going to have to enter that raw data into Minitab. And I printed this page out so I could have the numbers. So I'm going over to Minitab. And we're going to put stats, pop, quiz, scores. Okay, again, remember you want to always label the column of what you're putting in it. And then we're going to enter the numbers that are given in that list. We have 1, 2, whoops, 3, woo, 1, 2, 3, 3 again, okay, it doesn't like me this morning, 3 again. Then there's 4, 4 again, 4 again. Let me close some of these windows to see if this will speed up a little bit. So I have 3 4s. I have 5, and it occurs 4 times in the list. I have 6, and it occurs 4 times in the list. 7 occurs 3 times in the list. Whoops, be careful. I needed 3 7s, so there's 1, 2, 3. There's 2 8s, 1 9, and a 10. I do end up on the 22nd row, so I know that I've got 22 values entered. I'm going to double check that I didn't get something wonky because my computer was acting up. Okay, I've double checked my numbers and I've entered the raw data. So now I'm ready to calculate my confidence interval. I have stat, basic statistics, 1 sample Z. Again, we're doing a Z because we know the population standard deviation. This time we have 1 or more samples each in a column. I have the raw data. I have to tell it where the raw data is located. It's in column 1. My known standard deviation was given as 2. Options, I wanted the 90% confidence interval, and my alternative hypothesis will be not equals, always. I click OK. OK. And again, I get the results. Okay, so let me copy them over here. Let me scroll them down. Okay, so notice when I do these descriptive statistics, okay, again, it gives me the N, okay, which is my sample size. It does now give me the sample mean. Okay, so if I had been asked that question earlier, I can now go back and tell you that the sample mean is 5.500. That's given from or in Minitab if I need it. It also gives us, we don't need it, but it gives us the sample standard deviation. It calculates it. I don't need it, but it's calculated it. We don't need the SE mean. And we also still have that known standard deviation. We have our population standard deviation. Again, what we're primarily looking for is this interval of numbers here. That's our 90% confidence interval for the mean. Our lower bound, which is the first number in the parentheses, would be 4.799. Upper bound would be 6.201. I get those numbers directly from Minitab. The next question usually asks for the error bound for the population mean, which is a calculation we do by hand. It is the upper bound minus the lower bound divided by 2. So using the numbers that we got from Minitab, I would have 6.201 minus 4.799 divided by 2. You have to do the subtraction in the numerator first. So we have 6.201 minus 4.799. I'm using my handheld calculator. I have 1.402 divided by 2 is 0.701. So the error bound margin, or the error bound for the population mean, is 0.701. Then we write our conclusion. Okay, our conclusion would say, we estimate with 90% confidence that the true population mean statistics pop quiz score is between 4.799 and 6.201. My 4 is kind of sloppy. As it's not necessarily difficult, you just need to make sure whether you have summarized data or whether you have raw data, and you're going to have to pay attention to whether you have the population standard deviation or not. You also are ultimately going to have to pay attention whether the question is asking about the mean or about a proportion. With both the Z interval for the mean and the Z interval for the proportion, we can calculate the sample size. So let me toggle back over to the problems or to the PowerPoint. Sometimes when you're setting up your problem, you want to make sure that you collect enough data, because you don't want to have to go back and collect it a second time. That in terms of doing research could cost you money. It could also cost you time. So you want to ensure that you collect enough data from the beginning of the process. And so if we're using confidence intervals, we can estimate what our sample size needs to be based on the margin of error. If I have a particular desired margin of error, if I want to be within those 2 points or or within 3 points or within 5 points, I can determine what my sample size would be or should be. And so we're going to talk about how to do that. Again, this is something new. It is not typically discussed in Stat 1401. So this will be something new because it's just a formula. Now, it's not a formula that Minitab will do. So it's a formula that you will have to use a calculator to calculate. So if you're going to calculate or determine your sample size, okay, you have to know what you want your margin of error to be, which is usually represented by the letter M, margin of error. You have to know the population standard deviation, and then you have to know the critical value. There's a particular value that we use depending upon whether we're doing a 90% confidence level, a 95%, or a 99%. It's related to the normal distribution curve. Remember that if you know the population standard deviation, we are basing our calculations on our normal distribution that is symmetric, bell-shaped, continuous, and the means in the middle. The critical values are the areas where we would get to the point where we know the confidence level, or excuse me, we know that our population mean is not in that region. And it might be that it's on the low end, or it could be on the high end. Okay, so that's this critical value determines at what point are we beyond having a good estimate, so to speak. Your critical values give you that kind of that fence post where to tell you, oops, I've gone too far. Okay, it's just a fancy notation. It is a Z value. That's why you see the Z. And then it says alpha divided by 2. Your alpha, your significance level, is divided by 2 because it could be less or it could be more. Now, you don't have to know all that to work the problem, okay? But that's kind of the theory or the reasoning behind it. The formula is that critical value times your population standard deviation divided by the margin of error, and then that whole answer is squared. And the other thing that is different is we will always round up. Okay, this is one case where we do not follow the standard rounding rules. We will always round up because, again, you're thinking about whole units. Typically, with data, you're going to be collecting maybe surveys from people, or you're looking at reports, and you cannot have, half a report, a third of a report, half a person, a quarter of a person. So we always round up. Now, for these problems, at least the way they're set up in this course, okay, all of this information, okay, the margin of error that you want to have, your population standard deviation are going to be given in the problem. We find our critical value using a table. And I happen to know that that table is at the top or in the header of the midterm exam. So the table that you need will be given on the midterm exam. It's on slide 19. Basically, you would find your confidence level in the left-hand column, and the critical value from the Z table, the normal distribution, is given. The ones that are bolded, 90, 95, and 99%, are probably the three that occur the most or that are used the most. But we could do any confidence level. So I know that that table is given on the midterm. It's not something you have to memorize. I copied it this morning onto our Word document so that I would have it to reference as we're working through the examples. Okay. So here's our first example of finding the sample size. It said, suppose scores on exams in statistics are normally distributed. It is important to know in this case if they are normally distributed with an unknown population mean and a population standard deviation of 3 points. How many scores would the professor need so that a 90% confidence level would have a margin of error of 0.5 points? Okay, again, I'm not really doing a Z interval because I'm asked how many scores, but you need to realize this is or would be a Z interval because I know the population standard deviation. Okay, and I hope the fact that it does say how many scores, that's the question, okay, kind of lets me know that I'm trying to figure out the sample size. To figure out the sample size for a Z interval, I need the formula. Okay, it is the sample size equals, whoops, my critical value that's going to come from the table times the standard deviation divided by the margin of error, and that's squared. And guys, all of those numbers, well, two of the numbers are given in the problem, and we get the critical value from the table. Okay, so the first thing I'm going to do is I'm going to go back up and I'm going to look at my table. Let's see, we're doing a 90% confidence level. Okay, so we're looking for, look down the columns, confidence level, I find 90%. Here's 90%. So my critical value is 1.65. So all I'm going to do is read it directly from the table. Okay, so I'm going to write that down so I have it. Okay, so my critical value, which is Z alpha divided by 2 from the table, is 1.65. It tells me in the problem that my population standard deviation is 3 and my margin of error is 0.5. I have all the numbers that I need. It is flat out plug and chug. I'm going to put all those numbers into this formula. So I would have 1.65 times 3 divided by 0.5, and then I'm going to square the answer. Guys, remember, you have to follow order of operations. Order of operations would tell you to do what's inside the parentheses first, and inside the parentheses, I would do the multiplication first. So I'm going to multiply 1.65 times 3, which is 4.95, still divided by the 0.5, and then squared. I'm trying to walk through it so that you don't get messed up. If you are very proficient with the calculator, some people could put this all in at one time. Okay, so then I have 4.95 divided by 0.5, which gives me 9.9. Then I'm going to square it. So the last step is to square 9.9. And I get 98.01. Okay, it is a decimal value. We're always going to round up. So we're going to round to 99. My answer would be the teacher would need 99 scores so that she would have a margin of error of 0.5 points. If the scores are normally distributed with a population mean of 3.
Well, I thought it'd be like 98 because the 0, you can't round that up.
Nana, this is one case when you're doing these problems related to the sample size estimation where we do not follow standard rounding rules. The rounding rule for the sample size estimation is to always and forever round up. If there's any decimal piece to the problem, you have to automatically round up.
Okay, so that's why the 98.01 is, or you
Goes
round
to
that up to 99.
Yes, ma'am. Yes, ma'am.
Okay.
Okay, because you want to be sure. See, if I only do 98, my margin of error might be bigger than the 0.5 that's requested. But by doing one extra, by doing 99, I'm guaranteed that it's at least 0.5.
Okay.
It's better to do extra than not enough.
All right.
And so this is one scenario for sample size estimation where you do not follow standard rounding rules. You will always round up.
Okay, I see. Thank you.
You're welcome. Gabriella or Emmanuel, you have questions?
No.
Okay, I think I have another example of sample size estimation. The biggest issue that students usually have with the sample size estimation, quite honestly, because it is a formula, is basically not doing the calculations in the right order. So just be careful. So let's walk through another one, and then we're going to move on to T. It says a researcher is interested in estimating the mean monthly salary of sports reporters in a large city. She wants to be 95% confident that her estimate is correct. Assume the population standard deviation is 1100. how large a sample is needed to get the desired information and to be accurate within $150. Now, in this scenario, they do outright tell you the population standard deviation. They didn't call it specifically the margin of error, but it says to be accurate within $150. So you have to kind of be careful with the wording. They may not expressly say margin of error. But again, the fact that they've given me the population standard deviation, I know that I'm going to do a Z interval if I were calculating it. Okay, so it's just, you need to know this is a Z interval so that you know the formula to use. It also tells me she's doing it for the mean, okay, and it's a Z interval because I know the population standard deviation. Okay, this one also tells me that she's trying to estimate the mean monthly salary. And again, at this point, that's the only type that we've talked about. But again, by the end of today, we will also have talked about how to estimate the sample size for a proportion. So again, it's important that you recognize this one is about a mean, because that will help you to determine the appropriate formula to use. Okay. Again, my question says how large a sample. So again, hopefully that phrasing helps you recognize that you want to do the sample size estimation. To do the sample size estimation, you need your critical value, which will come from the table. You need your population standard deviation, and you need your margin of error. Okay, this is your population standard deviation, and M is your margin of error. This is your critical value, and it comes from the table. Okay, so my population standard deviation, it says, is $1,100. It says I want to be accurate within $150, so that is my margin of error. And my critical value needs to correspond to 95%. So I'm going to scroll back up to my table. And now I'm looking for 95%. Here's 95% confidence. So my critical value is 1.96. Okay, my critical value is 1.96. You'll have access, hopefully you've written it down, or it is on the PowerPoint, but you'll have access to the formula for the midterm. N equals the critical value times the population standard deviation divided by the margin of error, and that whole value is squared. Guys, it's straight out plug and chug. So I have 1.96 times the 1,100, which is my population standard deviation, divided by $150, which is my margin of error, squared. Again, the key thing here is following those order of operations. And the first thing I'm going to do is I'm going to multiply 1.96 times 1,100. And when I do that, I get a value of 2,156. Then I'm going to divide 2,156 by 150, which is my margin of error. It gives me 14.37333. Okay. Then I'm going to square that number. When I square that number, I get 206.592711. Okay, again, for the sample size estimation, you will always round up. So I should round this. I would need 207 items in my sample to ensure that I have a margin of error of $150 for the 95% confidence interval. Guys, don't overthink it and make it harder than it is. All of the information you need is given in the problem. You are simply plugging and chugging into a formula. Questions on sample size estimation. Okay, we're going.
Can we do one more example?
Okay. I may have to make one up.
What's that? On this one.
So you want sample size estimation?
Yes.
Okay, I may have to make one up because I don't have another one on the PowerPoint, okay?
Okay.
So let me see. Let's go back and maybe I can pick up one of these. Okay, I'm going to use this noise level problem. Let me put it in the right spot. Okay, let me rewrite it just a minute. Okay, I made this one up so that we could do another one because I didn't have another example. Okay, so it says noise levels at area hospitals were measured in decibels. The population standard deviation was 7.9 decibels. How many corridors should be sampled if the margin of error is 0.1 decibels for a 99% confidence interval? Okay. Again, two things jump out at me. Okay, it says how many corridors. So it's asking me for the sample size. Okay. It also tells me in the problem, it tells me that the population standard deviation was 7.9 decibels. I guess I should say decimals with an unknown population mean, because we need to know that it is related to the mean. Okay, otherwise I might think it's related to something else. Okay, so again, it initially asked me about the number of corridors, which is a clue I'm looking for sample size. It tells me the population standard deviation, and it has information related to the mean. Okay, and I kind of need to know those three things because this tells me that this problem is a sample size estimation for the population mean. And again, I know in this scenario that it is related to the Z interval because I know the population standard deviation. Now again, what that does for me is identifies the formula. Now at this point, you only have one formula, but again, by the end of today, you'll have two formulas and you'll have to know which formula to use when. Okay, so my formula for sample size is your critical value times the standard deviation divided by the margin of error, and that whole value is squared. All of the information that you need is either given in the problem or you can find it from the table. So our critical value for a 99% confidence interval is going to come from the table. And again, I know that that table is given on the test. Okay, it tells me that my population standard deviation is 7.9, and I want to have a margin of error of 0.1. So I need to go back up to my table. So I'm going to scroll back up for a minute. Scrolling back up to the table. This time I want 99%. Okay, the first column is my confidence level. So I'm going to scroll down until I see 99%. And then I read over to the next column that gives me the critical value. So my critical value is 2.58. So from the table, I know that my critical value is 2.58. Once I've identified all of that information, it becomes a plug and chug. I'm going to substitute all of the numbers into the formula. I would have 2.58 times 7.9 divided by 1/10. Now again, it's important that you follow order of operations. We need to do the parentheses first, and within the parentheses, you do the multiplication. So I have 2.58 times 7.9, which gives me, let me change colors, 20.382. I then have to do the division by 1/10. So 20.382 divided by 0.1 gives me 203.82. And then I'm going to square it, which gives me 41,542.5. 0.5924. So I would really need to sample 41,543 corridors in order to have a margin of error of 1/10 for my 99% confidence interval. Don't overthink it. Are you good, Nana?
Yes, thank you.
You're welcome. Okay, now let's switch gears and let's talk about t-interval. It's the same concept, guys. We're still creating that range of values for the population mean. The difference is I do not know the population standard deviation. Whenever I do not know the population standard deviation, we use the t-interval. The t-interval, and I may have it on the next slide. Let's see. The t-interval is based on the student's t-distribution. Okay. If you'll recall, and you may not, but let me see if I can draw it. I can get over here where I can draw. Okay. For the t-interval, we're applying the student's t-distribution. The student's t-distribution is very much like the normal, but it does not taper off the fast. It is still bell-shaped. It is continuous. It is symmetric about the mean. It does not taper off as fast, which means we have more area in the tails than we do for Z. That's the primary difference. And when we don't know the population standard deviation, we use the student's t-distribution or a t-interval. Again, there are conditions that if you were doing this in the real world, you would want to verify. We want to make sure we have a simple random sample, meaning all items in the population had a chance to be selected. Our sample size is greater than 30, or we know that the population is normally distributed. Not any different from what we had before. Again, for us, we're going to make the assumption that those conditions are met. In these scenarios, the biggest difference is instead of being given the population standard deviation, you're going to be only given the sample standard deviation. You will still be told the sample mean. You will still be told the sample size. You will still be told the confidence level. But instead of having the population standard deviation, you will have the sample standard deviation. The problems related to the t-interval can be presented in the same way as the z-interval. You can either be given the summarized data or the summarized statistics, or you can be given the raw data. The keystrokes for Minitab are on the next slide that I went past. And let me tell you what slide number it is. It is slide number 3. Okay, so the Minitab instructions for calculating the t-interval are on slide 3. The primary difference is you're going to choose the command 1 sample T instead of Z. But beyond that, the process or the clicks are virtually the same. You'll still be given or calculating the lower bound and the upper bound. We still have to calculate the error bound for the population mean manually by hand using the formula. It's the same formula, upper bound minus lower bound, and then divided by 2. The conclusion is written in the same way as the one we had for Z. The concept of a confidence interval is not changing. It's a matter of which one should I calculate. We calculate Z, as in zebra, if we know the population standard deviation. If I do not know the population standard deviation, then I'm going to calculate T. But the process itself is not changing. So I'm going over. I've got examples here, but I'm going to go over to my paper. I transferred them over this morning. So the first example says, suppose that a committee is studying whether or not there is waste of time in our judicial system. It is interested in the mean amount of time individuals waste at the courthouse waiting to be called for jury duty. The committee randomly surveyed 81 people who recently served as jurors. The sample mean wait time was 8 hours with a sample standard deviation of 4 hours. Construct a 90% confidence interval for the population mean time wasted. And there really should be, it should say true population mean time wasted. So as I'm reading through that problem, initially what jumps out at me is that it gives me the sample standard deviation. Nowhere in this paragraph does it mention population standard deviation. So there's no mention of the population standard deviation. But it does give me, I am given the sample standard deviation. So I will construct a T interval. Okay, there is no mention of the population standard deviation, but I am given the sample standard deviation, so I will construct a T interval. For the T interval, I need pretty much the same information that I needed before. I have to know my sample mean, I'm going to know the sample standard deviation, I have to know the sample size, and I have to know the confidence level. All of that information is given in the problem, which also tells me in terms of what I'm going to do in Minitab that this problem involves summarized data. Again, in this problem, if you look back at it, I do not have the list of 81 data values. It does clearly identify the other things for me. It says they surveyed 81 people. So my sample size is 81. If I keep reading, the sample mean wait time was 8 hours. Okay, so my sample mean was 8. With a sample standard deviation, which I already underlined, with a sample standard deviation of 4 hours. So my sample standard deviation is 4. And it says construct a 90% confidence interval. Okay, so my confidence level is 90%. So I've pulled from the problem all of my information, and I'm going to go out to Minitab to calculate my test statistic, or my confidence interval, excuse me. Again, the key strokes that you'll use are on slide 3 of the PowerPoint for the T interval. So we would go stat, basic statistics, 1 sample T. We have summarized data. My sample size was 81. My sample mean was 8. My standard deviation was 4. All of that was given in the problem. Options. We're doing a 90% confidence level, and my alternative hypothesis will always be not equal. Click OK. OK. And I get very similar results. It really looks just like what I got for Z. Again, it does identify for you, remind you of your sample size. It reminds you of your sample mean. It reminds you of your sample standard deviation. You don't need the SE mean. And then you have your 90% CI from U, which is 7.260, 8.740. Just as before, the first number in the parentheses is your lower bound. That's the lowest value that your population mean could be. The second number in the parentheses is the upper bound. And I know that on the test and on the quiz, homework quiz, you're going to have a question that says, what is the lower bound? you would just write the number down, 7.260. There's also going to be a question, what is the upper bound? It is 8.740. So you're just recording the results that you get from Minitab. You're also asked to determine the error bound for the population mean. And again, even with the T interval, this is a hand calculation where you have to use the formula and a manual calculator. The formula has not changed. It is still the upper bound minus the lower bound, all divided by 2. Again, it is simply plugging and chugging, putting the numbers into the formula. So I have 8.740 minus 7.260, all divided by 2. Guys, again, remember, you have to do the subtraction in the numerator first. Okay, follow order of operations. So using my handheld calculator, I'm going to do 8.740 minus 7.260, which gives me 1.48. 1.48 divided by 2 is 0.74. Now again, remember, even with these problems, D2L likes you to put that leading 0. So you need to type 0.74. And then lastly, we write our conclusion. The phrasing for the conclusion is the same as it has been. We would say, we estimate with 90% confidence that the true population mean, see, what was this question talking about? Mean time wasted for jury duty is between 7.260 hours and 8.740 hours. Again, you have to put in that phrase, true population. Because again, if you notice how the question is worded, it says true population mean. Questions? Same process with just a little bit of a twist because you do not know the population mean. You can also have these problems presented with the raw data. This problem reads, you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, which is assumed normal, from which you took the data. Okay. So a couple of things here. I see the word mean. I also notice that there is no mention of the population standard deviation. Okay. But there's also no mention of the sample standard deviation. However, I have the raw data that would allow me to calculate the sample standard deviation. Okay, again, guys, you got to think this through. If you are not given the population standard deviation, you're out of luck. You cannot do a Z interval. But then as you read through this problem, it doesn't mention the sample standard deviation either. But whenever you have the raw data, we learned back in module 1, when I have a list of data, I can calculate things like the sample mean, the sample standard deviation, the sample median, the range, the quartiles. I can calculate those statistics. So I have the raw data that's going to allow me to calculate the sample standard deviation.